We now move on to question number 5. The question asks, on what intervals is the graph of y equals 3x to the 4th minus 16x cubed plus 24x squared plus 48 concave down? So, how do we figure that out? Remember, concavity is associated with the second derivative. So our goal is to find the second derivative. A graph is concave down, if the second derivative is less than 0. It should make sense. Down should be associated with negative, while up should be associated with positive. So if the question says on what intervals is the graph of that function concave up? Again, we find the second derivative, but we look for the interval where the second derivative is positive. So let's proceed. Y, we will now find y prime. Y prime is equal to 12x cubed minus 48x squared plus 48x plus 0. We're done with the first derivative. We now move on to the second derivative. Y double prime. Y double prime is equal to 36x squared minus 96x plus 48. We take this and set it equal to 0. So you want to see where the second derivative is equal to 0 so that we can get our possible points of inflection. Set 36x squared minus 96x plus 48 equal to 0. Notice that all those numbers are divisible by 12. Divide everything by 12, including the 0. You get 3x squared minus 8x plus 4 is equal to 0. Factor. If you don't want to factor, fine. Use the quadratic formula. How do we factor? Well, we multiply 3 by 4. We get 12. We look for two numbers that multiply to 12 and add up to negative 8. So we want the same two numbers to multiply to 12 and to add up to 8. They are negative 6 and negative 2. So we have 3x squared minus 6x minus 2x plus 4 is equal to 0. Group the first two terms, factor out a 3x. 3x times x minus 2. Factor out a negative 2. So now we're happy. We see that the two quantities are identical. We can now factor x minus 2. So this is x minus 2 times 3x minus 2 equals 0. Using the zero product property, we have that x minus 2 is equal to 0, or 3x minus 2 is equal to 0. Skipping a few steps, we get x is 2, or x is equal to 2 over 3. We draw our number line. After drawing our number line, we will make a sine graph. We put the number 2/3 and the number 2. On the number line, what you should do right now actually is go back to the original second derivative. I'm going to erase all this work. For the original second derivative, we actually have y double prime is equal to 12. We factor out the 12, and then we already have the other two factors, x minus 2 and 3x minus 2. And we make a sign graph with the second derivative. So, let's use a number such as 0. 0 minus 2 is negative 2. 0 minus 2 is negative 2. A positive times a negative is a positive. A number between 2/3 and 2 is a number like 1. 1 minus 2 is negative. 3 minus 2 is positive. 12 is positive. A positive times a negative times a positive is a negative. Finally, go to the last interval, the interval of numbers bigger than 2. The interval that contains numbers bigger than 2. Choose a number bigger than 2, whatever you want. 3 is a good choice. And so we have 12 is positive, 3 minus 2 is positive, and 9 minus 2 is also positive. A positive times a positive times a positive is a positive. Read the question one more time. Big clue, concave down. We said the graph of a function is concave down when the second derivative is negative. So our answer is 2/3 is less than x, which is less than 2. So the graph of y is concave down on the interval from 2/3 to 2. We move on to the next question. In the next question, we're asked to find the antiderivative of e to the 2 over 2, a t over 2. We rewrite it. 1/2 e raised to the power of 1/2 t dt, and we use u substitution. We say, let u be equal to 1/2 t. Then du is equal to 1/2 dt, and 2 du is equal to dt. Make your substitutions. We have 1/2 the antiderivative of e to the u, and replace dt by 2 du. Bring the 2 in front. 1/2 times 2, the antiderivative of e to the u du. 1/2 times 2 is 1. The antiderivative of e to the u is e to the u plus some constant c. So our final answer is e raised to the power of t over 2 plus c. We now move on to number 7. Number 7 might be a little bit more difficult because you have to use the chain rule. Not only do you have to use the chain rule once, but you'll have to use the chain rule 2 times. The first thing that you want to do is rewrite the question. This is the derivative with respect to x of cosine of x cubed raised to the power of 2. So when you look at this, just look at it as the fact that you're taking the derivative of some quantity raised to the second power, and use the chain rule. What is the derivative of something raised to the second power? Well, the derivative of something raised to the second power is 2 times that blob raised to the first times the derivative of that blob. So this is 2 times cosine of x cubed raised to the power of 1 times the derivative of cosine of x cubed. We continue. cosine of x cubed is also a composite function. Now you have to use the chain rule again. So you have 2 times cosine of x cubed. I know it's raised to the first, so anything raised to the first power is itself, times the derivative of cosine of x cubed. The derivative of cosine of blob is negative sine of that quantity times, like I said, we have to use the chain rule once more, the derivative of x cubed. So this becomes 2 cosine of x cubed times negative sine of x cubed times 3x squared. This is negative 6x squared cosine of x cubed times sine of x cubed. And now you are done.